Hello again everybody, I am Radu Horoiu, Professional Services Engineer at Infinet Wireless. Thank you very much for joining today's webinar. We will talk, as I mentioned earlier, about 1+1 links, or more precisely about the Infinet Wireless solutions for redundancy and link aggregation scenarios. Today's agenda is comprised of 5 items. In the beginning, I will explain to you what are the 1+0, 1+1 and 2+0 configurations. Then I will list some of the most common link redundancy scenarios, and I will explain how does the new failover feature work with the Infinet Wireless R5000 devices. In the third item, I will present some link aggregation and load balancing scenarios that you can implement using Infinet units. Next, I will show you what are the powering options for all the different Infinet point-to-point and point-to-multipoint solutions, in case you don't want to use the standard power supply units that are bundled with the equipment. And in the last item of today's presentation, I will summarize the main benefits of implementing redundancy and link aggregation in your wireless networks. To begin, let's see what are the different redundancy schemes that you can create using wireless network devices. First, the 1+0 configuration means that you have just one regular link, ordinary, with no possibility to implement redundancy at all. Then we have 1+1, which is the most typical redundancy configuration, and it involves having 2 parallel wireless links between the same points, but only one of these links is active at a given moment. In other words, you have a main link and a backup link, which is configured as failover. Both links can be configured using the same operating frequency. The backup link is not operational for as long as the main link is up, and it becomes active only if the primary link is interrupted somehow. I will explain to you in more detail how does the failover mechanism work in a few minutes. The 2+0 configuration is also comprised of 2 parallel links, but this time both links are operational at the same time. This means that besides redundancy, you can implement mechanisms like link aggregation to effectively double the link capacity. You can also achieve full duplex communication by forcing all the uplink data to go through only one link and all the downlink data to go through the other link. Of course, you will need different frequency channels for each link in this configuration. Moving on to the most typical 1+1 link scenario that I want to show you, which is comprised of 2 parallel links created using Infilink 2x2 Pro units. The devices can have either integrated or external antennas, and both links can be configured using the same operating frequency. The backup or secondary link is configured as failover. You will find details about how to perform the failover configuration in the files section, as I mentioned in the beginning. There is a PDF file over there that you can download, which contains all the scenarios presented during this session and more. In the next few slides, I will explain how does the mint failover mechanism work in this example. First of all, PRF interfaces and joins need to be configured on the master units in order to create a unified mint area at the master side. The switch groups need to be different for each link to avoid the local loops. STP must be disabled. This is very important because it could interfere with the failover mechanism. This means that there will still be some short-time loops, but only at the beginning when you have powered up the units, both links. After one of the radio links is cut off by the failure mechanism, the loops will no longer be an issue. In this example, it is enough to configure failover on the backup master only. You will find a command that activates it in the PDF document that I told you about earlier. The failover mechanism is really simple, and it works like this. When the backup master unit can see one MAC address via 2 different paths, it will shut down its radio port. The physical address that should be monitored in this case is the MAC of the radio interface of the main slave unit, as you can see marked in the picture. This address must be input manually along with the failover command via CLI. There is also an automatic mode for failover, but it is recommended only when the mint costs of the links are different, which is not the case in this example. Of course, the automatic failover is covered in the configuration document, so you can find more details there. So after the second radio connection has been cut off by the failover mechanism, the backup link will be on standby for as long as the main link is operational. During standby, the RF port of the backup master will be completely shut down, while the backup slave will be silent. It will just listen on the radio, waiting for the master's command. This means that both the main and the backup links can be configured using the same frequency channel without having to worry about interference during operation. Now, in case the main link fails for any reason, the backup master can no longer see the configured MAC address through its Ethernet interface. This triggers the restart of the radio interface of the backup master, and after a short idle time of a few seconds, the backup link will be up and it will take over the traffic load. In case the main link is re-established after a while, the backup link will stop its transmission and it will go again into standby mode. The next common redundancy scenario involves providing backup for a high-speed XG link using R5000 units. The XG link is the main connection between the two switches in this example, while the R5000 link is configured as backup using the failover option. Of course, the links can be configured using the same frequency like in the previous case. It is important to mention also that only the R5000 units can be configured as failover. The XG link cannot be used as backup in this configuration because the failover option requires the mint set of protocols, which the XG doesn't support. In the next picture, we have another important redundancy scenario in which an R5000 link is used to provide backup for a fiber link. Actually, with R5000 units, you can back up literally anything as long as one MAC address is seen by the master unit through two different interfaces. It doesn't matter if the main link is wired, wireless, or if it was created using Infinet units or devices from another manufacturer. It makes no difference. The configuration of the backup link when we have one main wired or wireless non-mint link is mostly the same as in the previous case when we had two R5000 links. PRF interfaces and joins should be configured on both the master and the slave unit to extend the mint area over the main link. And this time the physical address that must be monitored for failover can be either the RF or the Ethernet MAC of the backup slave unit. It works with both. Next, I want to show you a very challenging redundancy scenario. If, for example, you have several links of great importance built using Infinet 2x2 Pro units and you don't have any more space on the tower to install the backup antennas, how do you implement redundancy? Well, the answer is in the next slide. And in the picture, you can see how you can connect one external antenna using RF cables and RF combiners. This setup enables you to implement redundancy when you don't have enough tower space to install new antennas. The combiners must have good isolation between the input ports to prevent leakage to the other unit. The backup link is configured as failover. Both links can have the same frequency channel configured. There is not much difference from the setup where we had separate antennas for each unit. The links will interfere with each other only at the beginning, right after powering up the units during the negotiation process. After a little while, both links will be up. The backup master will see the MAC of the main slave via two paths, and it will shut down its radio port. From now on, the backup link will be on standby, like I explained earlier. And obviously, if you have multiple frequency channels, you can aggregate the links for more throughput, of course. But you also must bear in mind that you will lose about 3 dB at each 2x1 combiner, and you should take this into account when you calculate your RF link budget. Moving on to the link aggregation and load balancing scenarios that I want to show you today. And in the first scenario that you can see in the picture, the link aggregation is performed using third-party switches that support LACP. So the LACP in this example is LACP configuration is performed only on the switches, And the Infinet units have just the default switch group configured with the Ethernet and RF ports added to it. Now the problem with this setup is that both links must provide similar throughput to ensure good operation. If the links are unbalanced, the switch will not take this into account when computing the traffic paths, and thus the overall performance can be heavily impacted. Most common switches implement load balancing only based on source or destination MAC or IP. The mint areas should not be merged in this case. We will see in the next slide what happens if we merge them. If you create a single mint area, you can no longer use LACP in this example because it doesn't work properly with joined interfaces in this particular case. But instead, you can configure the old version of Mint redundancy and full duplex transmission, which have been covered during another webinar in the past. Again, you will find these scenarios in the configuration document from the file section. In the next scenario, we have the solution for the problem of the previous setup. This time by using the Infimox devices of Infinet Wireless, instead of the regular switches, optimal operation is ensured even when the links provide different capacities. Infimox supports Mint, so it is aware of the bitrate on each link. This means that it will also take the link performance into account when computing the traffic path. In this setup, the Mint areas should be unified by creating PRFs and joins on all units, including the Infimox. The lag interfaces must be created only on the Infimox devices, and the R5000 units can be configured as simple repeaters. This way, only the Infimox devices will take decisions regarding the transmission path for each packet, and the wireless units will simply forward the traffic just like simple switches. Next, we have some useful information about how you can power the different types of Infinet devices if you don't want to use the included PoE adapters. And first, we have the Infilink XG, Infilink 2x2 Pro, Infiman 2x2 base stations, and QMXB. These are the more serious high-performance Infinet units, and as you can see in the table, they are all compatible with .38t, so they can be powered using any PoE switch or other device that supports this standard. This means that you will have no trouble integrating these units into any standard powering setup that you might have prepared at your sites. The Infilink 2x2 Lite and the CPEs, on the other hand, do not support the .38t standard. Instead, they use passive PoE, and this means that you will need some specific switches or converters to power them if you prefer not to use the included adapters. And here are a few examples of such devices that you can use for powering the CPEs and the Infilink 2x2 Lite units. Next, I want to summarize some of the most important benefits of implementing redundancy and aggregation in your wireless networks. And I would like to start with the most obvious benefit, which increased reliability. Of course, the Infinet units are extremely reliable on their own, as you probably know, but if you want to be fully covered, even in the unlikely event that one link may break down, an extra backup link will offer you that additional peace of mind. The next important benefit is that you can aggregate multiple links to achieve a much higher total capacity than you would get with a single link. Of course, the aggregation setup also offers redundancy, so if one link fails, the traffic will go through the other ones, and it can also provide good load balancing, depending on the type of device that you use to configure the aggregation. The Infinet devices implement a very powerful hash function that takes many more parameters into account than a common switch. Another advantage is that the overall costs can sometimes be reduced by installing backup links, because in some situations it may be much cheaper to purchase an extra link from the beginning compared to the expense generated by the loss of business critical data in case of failure. The last important benefit that I want to highlight is the possibility to implement full duplex operation. As I mentioned earlier, you can force the uplink traffic to go through only one link and the downlink traffic to go through the other link by changing the costs of the means routes. Of course, the configuration instructions for this scenario can also be found in the PDF document that we have prepared for you. In the final part of today's presentation, I will show you some practical situations in which it is highly recommended to install redundant links. First, we have the remote sites from very distant locations, which can take a very long time and effort to get to. In some cases, the location is only accessible by helicopter, so only the fuel used to get there might be more expensive than a backup link. This is why you should consider implementing redundancy from the beginning in such situations. Another example is when the procedure of getting to the site is very complicated. This picture is from a bridge over the Bosphorus Strait in Turkey. The location itself is easily accessible, but in order to get permission to climb up to the equipment, you have to go through the approval procedure, which can take a long time, during which the link will be down. For the enterprise last mile connectivity, the redundancy is extremely important. In the natural resources industries, for example, a lot of money can be lost in the event of link downtime. So the backup links are usually mandatory in these cases. The 2+0 configurations can be implemented in situations when you require a higher capacity than what can be provided by a single link, or when full duplex operation is mandatory. As I mentioned earlier, redundancy is also ensured in these scenarios, but you must make sure that you have different frequency channels available for each link. So this brings us to the end of today's presentation. Thank you very much again for joining this webinar, this session. I hope it was useful for you, and I hope to see you again during the next webinar, which will be next month.